Good afternoon students. Today class I am going to discuss about uniform circular motion. What is uniform circular motion? If a body is moving in circular path. For example, let us take a body moving in circular path with uniform speed. So, a body moving in circular path has uniform speed, but the direction changes, right? How we calculate the direction? By drawing a tangent. See here, the speed, the magnitude of speed, it remains constant, but the direction of the particle keep on changing. So, it is not possible to change its direction without an external force, as we already learned that. To change the direction or magnitude of a particle, it should be under external force. So, what is the force that is acting on this particle to change its direction is called centripetal force. So, that external force acting on the point, each and every point on the circular path to make the particle to move in circular direction as well as to change its direction is called centripetal force, and it acts always directed toward the center of circular path. See, in all these cases the force is acting towards the center of circular path. That force is called centripetal force. See, we can define as, it is defined as the force acting along the radius towards the center of circular path along which the body is moving with uniform speed. That force is called what? Centripetal force. So, as we said that the direction is always towards the center. Okay, we call this as what? Centripetal force. Right. Now, where we can observe the centripetal force? First, what is the formula for the centripetal force? In the previous chapter, we already derived an expression for centripetal acceleration, right? What is centripetal acceleration? Centripetal acceleration. AC is equals to what? V square by R omega square. As we know, according to Newton's second law, F is equals to mass into acceleration. What is acceleration here? mv square by r mr omega square. This is called what? Centripetal force. So, that is the magnitude of centripetal force that acting on the body which is moving in circular path. Okay, what is direction? Toward the center of circular path. Where we can observe this? Let us take, if you want to experience, tie a stone to a thread, rotate the stone. For example, assume that this is a stone and now I am rotating this one. So, if it is moving in circular path, the wire that is connected is acting toward the center, right? So, the tension in the string is centripetal force. Next, planets revolving around the sun. So, the gravitational force that present between the sun and the planets make the planets to revolve. So, there what is centripetal force? Gravitational force causes the planets to move in circular path. Similarly, we have already learned electrons revolve around the nucleus in circular orbit. So, there which force make them to revolve? Electrostatic force. In all these cases, centripetal force varies based on the movement of particle. If it is revolving around the sun, what force is present? Gravitational force. If electrons are revolving around the nucleus, the force present is what, ma? Electrostatic force. Okay. Now, as already learned that for every action there is equal and opposite reaction. If a particle is moving a force is acting toward the center, that is called what? Centripetal force. So, according to Newton's third law, there should be an equal and opposite force, right? So, that force we can call as centrifugal force. So, when a body moving in a circular path, because of inertia of direction of force appears to act on the body away from, because centripetal force is acting towards the center, the centrifugal force acts always away from the center. It is called centrifugal force, but there is no origin of this force, because it is a reaction force. There is no origin. So, that is why it is called fictitious force or pseudo force. It comes into play when there is a body moving in circular path. Means here, to make the body to move in circular path, one force acting toward the center, that is called centripetal force, and another force acting always directed away from the center, that is called what? Centrifugal force. When both forces are equal, the body is in equilibrium. So, this is about what? Circular motion. In circular motion, what are the forces acting here? Two forces. One, centripetal force always acts toward the center, and centrifugal force is a pseudo force. Because of action, it acts away from the center. Okay? So, this is about what? Centripetal and centrifugal forces. Now, we are going to learn the very important question, 5 marks of this chapter is what? Motion of a car on a banquet road. On a banquet road. Very important now. Listen students, motion of a car on a banquet road. What is banking? Have you seen that when there is a circular turn, most of the persons who doesn't know proper riding get skid and fall down, right? Yes or not? Why? Because when we are making a turn, the centripetal force acts toward the center, so that we skid and move away from the center. And the best way to assume this one is, if we won't reduce the speed, surely we will fall. Yes or not? When a circular turn is came. For example, have you seen a bike race? Yes. In a bike race, there are a lot of turns will be there, but they can't decrease the speed of the bike. Instead, what they will do? They will bend the bike toward the road and move away. So that without changing speed, by changing the angle, they are moving without skidding. So, to avoid skidding on a circular turn or to provide needed centripetal force, we do banking. What is banking is very simple. Have you seen the circular turn? Inner edge is lowered and outer edge is slowly, very small amount of outer ring road is rising. That is called what? Banking. The raising of outer edge of a curved road as compared to inner edge to provide necessary centripetal force to avoid skidding is called what? Banking. How much speed we should move or what is the angle we should make, we are going to calculate here. Let us consider we raised the outer road to inner road by an angle theta. Assume that this is the angle we made, and let us consider a vehicle or a car is moving with some velocity. Now, a car is moving with some velocity in a curved road. In a curved road, there exist 3 forces, right? How many forces will act here on the body? 3 forces. What are the 3 forces acting? First one, the weight of the car acting downwards. A body of mass m and velocity v moving on a circular road has 3 velocities. What is the first one? Weight of the body acting downwards. Second one, What is second one? Normal reaction acts or not? Yes. This is normal reaction. Actually it is making some angle. So normal reaction making an angle theta with vertical. And finally frictional force. See the diagram now, it is very important ma. So it is making an angle theta. Okay, let us draw a vertical. So this is the vertical. So it is making angle theta, and you know that this is normal and this is n cos theta. As it right? Horizontal component of the vertical is n cos theta. And next one more component acts. What is that? This is vertical component, n sin theta. What about the friction? So the centripetal force is acting in this direction. Centripetal force acting in this direction. Friction acts in this direction, right? Making an angle theta. Yes. So it is also making an angle theta. Then this is Fs cos theta and this is Fs sin theta. See, I will draw again here. A car is moving on a curved road. Its weight exactly act downwards. That is mg. Now, if you draw a vertical, that is called normal reaction. But here normal reaction is not making an angle, so it is moving like this. So with respect to vertical, this is vertical. What is the angle making here? So this is what? N cos theta, and vertical component is n sin theta. Centripetal force acting toward the center, then frictional force act in this direction, that is Fs or Fr. So this is Fs cos theta and this is Fs sin theta. Okay. Now we should equilibrium all the points, otherwise it will fall down, right? Yes. See in the diagram, say what are the, to be equilibrium, what happens ma? N cos theta is acting upwards, Fs sin theta and mg is acting downwards. So from the adjacent figure, what we can write here? N cos theta is equals to mg plus Fs sin theta. In the similar way, this is centripetal force. So F is equals to n sin theta plus Fs cos theta. So consider this as equation number 1 and 2. We know very well what is Fs, static friction or rolling friction, anything. Fs is directly proportional to n. That implies Fs is equals to, what we can write here? We should place coefficient of static friction, right? What is that? F is equals to what? Mu s into n. And what is centripetal force? F is equals to mv square by r. Okay. Substitute these two equations in any one of the equation. What you can hit here? For example, if you substitute here, or here, what do you get from equation 1 first? What is equation 1? N cos theta is equals to mg plus mu s n into sin theta. Send mu s and sin theta here. N cos theta minus mu s n sin theta is equals to mg. What is common? N cos theta minus mu s sin theta is equals to mg. So, from this we can easily substitute n. What is n? N is equals to mg by cos theta minus mu s sin theta. This is equation number 3. So, substitute equation number 3 in 2. What do you get? What is f? mv square by r is equals to n. What is n? mg sin theta by cos theta minus mu s sin theta plus what is fs first? Mu s n. What is n? mg cos theta by then same cos theta minus mu s sin theta. Okay, what is common here? mv square by r is equals to mg if you take common sin theta plus mu s cos theta by cos theta minus mu s sin theta. Cancel, not v square, only m will get cancelled. Divide complete equation with cos theta on both sides. V square by r is equals to g into sin theta by cos theta plus mu s cos theta by cos theta divided by cos theta by cos theta minus mu s sin theta by cos theta. Sin theta by cos theta is what? Tan theta. Cos theta cancel, cos theta cancel. What we want? Velocity, right? V square is equals to rg into tan theta plus mu s by 1 mu minus mu s tan theta. So, this is the velocity we can move on a banked road so that we should not fall on the surface. Rg into tan theta plus mu s by 1 minus mu s tan theta under root. So, for example, if the surface is very smooth surface, means if the friction present between the surface is 0, then mu s is equals to 0, this is also 0, right? Then what you can write? V square is equals to rg tan theta or V is equals to root of rg tan theta. So, this is the angle we should write that so that we cannot skid on the surface, or we should bend the bike in such a way that tan theta is equals to V square by rg. So, this is the safe speed that can move on a circular path which is raised by an angle theta. So, just listen again. We have taken a car which is moving on a circular path which is banked at an angle theta. Okay, how many forces are acting here? See, for example, this is the curved path, weight is acting downwards, this is mg and this is normal, this is n cos theta making an angle theta and this is n sin theta. As we know, this is centripetal force. What about friction force? Acts this direction, this is Fs. So, this is theta again, F cos theta or Fs cos theta, this is Fs sin theta. So, we are balancing the equation, n cos theta is equals to F sin theta plus mg. Yes, n cos theta is equals to Fs sin theta plus mg. In the same way, n sin theta plus F cos theta is equals to F. So, we have taken F is equals to n sin theta plus Fs cos theta. As we know very well that centripetal force is directly proportional to normal force, Fs is directly proportional to n, Fs is equals to mu s into n. We substitute that value. Okay. Now, n cos theta is equals to mg plus Fs means mu s into n sin theta. From this we evaluated n. What we got as n? Mg by cos theta minus mu s sin theta. Substitute this value in equation number 2. What is equation number 2? F is centripetal force, nothing but mv square by r. That equals to n. What is n? We got the value, we substituted here, and here also we substituted. From that we got m is common, so get cancel on each side. Now dividing this equation with cos theta on both sides. Sin theta by cos theta plus mu s cos theta by cos theta. Cos theta by cos theta minus mu s sin theta by cos theta. Sin theta by cos theta is what? Tan theta. Cos theta cancel. So what you got? Tan theta plus mu s by 1 minus mu s tan theta. So if the surface is very smooth, mu s is 0. So the safest speed to move on a circular path with a velocity is what? V is equals to root of rg tan theta, or otherwise we should bend in such a way that to get we should not skid, that is what? Tan theta is equals to what? V square by rg. Okay. So next there is one small concept and some problems on this one. With this chapter will complete by tomorrow. Thank you, students.